Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. Please try to share, subscribe. Okay, very good. Please subscribe for me. All right, so we are going to look at vectors. We have already looked at bearing. Now we are looking at vectors. And we said that a vector is any quantity which has what? Both magnitude and what? Direction. Okay, sorry. Which have both magnitude and direction. But when it comes to scalar, we have a vector and a scalar. I didn't write the definition of the scalar here, but for the scalar it has only magnitude but no direction. Is that okay? So like distance, when you say that you are going to 2 kilometers distance, it's only magnitude, but for the 2 kilometers that you are covering, we don't know whether it's moving to the east or the south or the west or 60 degrees. Do you understand what I'm trying to say? So once that east, west, or the angle comes in, that comes with what? The direction. So when you have the direction and the magnitude is what? A vector. But when you have only magnitude without direction, then it becomes what? Scalar. Very good. So these are examples of vector. We have numerous of them, but I have just three for you: velocity, displacement, weight, etc., etc. Now let's look at the representation of vectors. How do you represent vectors? Okay, now one, free vector. We are saying that a free vector is a vector that do not start from the origin. Okay, it's a vector that do not what? Start from origin. So I have a nice diagram here for you. So this is a diagram. This is a vector you are talking about. So why are you saying that this is a vector? This is the distance from A to B is the distance, and the arrow there is showing you a direction where it is moving towards. So it's a vector. So AB, vector AB. This is the origin, okay? This side is the origin, and it's not starting from the origin. So a vector that is not starting from the origin is called a free vector. Is that okay? Very good. Now let's also look at, so this I write it, AB. So the direction is showing that we are starting from A and ending at what? B. That's the direction. AB is equals XY. This X and Y is called components. So for the X is called X component, the Y is called Y component. Is that okay? Very good. And this thing that is written is called a column vector. You see how it is written? Okay, so it's called a column vector. So you should take note of that. Position vector. It's also a vector that starts from what? The origin. So that's the opposite of the free vector. So when you have a vector that is starting from the origin, that is called a position vector. So we have example here, a nice diagram here. You could see that this vector is starting from the origin. So vector O is starting from O to what? A, and it is like that. So that's what we mean by a position vector. Let's continue. So now let's look at the example or the three of it. We are still under the representative of vectors. Okay, so column vectors, I have already mentioned this, and this is how it is written. Okay, it is written in the form like this. So the example of it is AB equals XY. Then we also move to inverse or negative vector. Now for this one, you should be careful with it. If vector AB is having this XY, then the inverse of vector AB is written as BA. So the inverse is just you turn, this is AB, you just turn it to become BA, becomes inverse. So in this case, because you are turning it, something happened. Inverse of positive is negative. Inverse of negative is positive. Is that okay? So if you look at this one, AB was XY. So if I turn it to become BA, then I just negate this. That gives me negative of XY. Simple as it is. So this negative here will multiply this X, will multiply this Y. That gives you the negative X, negative what? Y. Simple like that. Okay. So let's look at some examples here. If Mn equals 35, find Nm. So you see that is the turning side of it. So solution. So Mn equals 35. So if I want to find Nm, vector of it will be the negative of this one, the answer given, which is 3, 5. And this will give me negative 3, negative 5. Is that okay? That is the 1. 2. If AB is giving us negative 2, 4, then BA, that's what we have to find, will be negative outside negative 2, 4. Please, you don't have anything like this 2 over 4 there. It is wrong. It's a vector, so there won't be any division sign. And this will give us negative 2. Now negative multiplied by negative will be positive 2, and this gives you negative 4. So this is how we solve inverse or negative vectors. Now the last one here is zero vector. Zero vector is a vector which has all its components to be 0. Okay, so example of this is that, let's say if I have vector AB is equals to 0, 0. See that all the components is what? 0. So when you have a vector like this, it is called zero vector. Zero vector. Is that okay? Thank you very much for watching this. Please try to share to your colleagues.